All right, so now let's talk about the scientific method. So the scientific method is going to be an organized way of solving problems. So let me give you an example of how the scientific method might be used. So the first step in the scientific method is to make an observation. So I'm going to take this pen and I'm going to let go of it, and then you notice that it did something. So did you notice that it fell? So that's an observation. So then the second step in the scientific method is to pose a question. And so my question is going to be, why did the pencil fall? Okay, then the next step is to come up with a hypothesis. So a hypothesis is going to be an answer to that question. And so I'm going to say that it's magnetism. So that the force of magnetism is going to be drawing this pencil down to the table. Now hopefully you know it's not going to be magnetism that does it. But let's just say that, because sometimes in the scientific method you make guesses that are wrong. And so let's just go with this and say that we think it's magnetism. Okay, so then the next step in the scientific method is to do some research. So if you think that it's magnetism that's causing this thing to fall, then you're going to get onto the internet and start to research magnetism. So find out how magnetism works and what causes it. Okay, all right, so then the next step is to come up with a experiment. So our hypothesis, our working answer to our question is that it's magnetism. So now we're going to come up with some kind of an experiment. All right, so what I'm going to do is this table here that the pencil fell on, I'm going to rip it up. Okay, I could do it if I wanted to, but I'm not going to. So I'm going to rip up this table and I'm going to lift it up into the air, and then I'm going to flip it upside down, okay, and then I'm going to take the pencil and I'm going to put it underneath it and I'm going to let it go, and according to my hypothesis, if it's magnetism, what should happen? Okay, it should be attracted to it. So then I let it go and it still doesn't work. All right, so I say to myself, oh, I know that the closer two magnets get, the stronger they get. So I get my pencil and I hold it closer to my hand, this time at the table, and I let it go, and again it falls. So no matter what I do, the pencil keeps falling, and so what that means is that I need to change my hypothesis. Okay, and this time, what do you think my hypothesis should be? Gravity. Okay, so then I start over again, and I'll do my research, but this time, instead of doing my research on magnetism, I'm going to do my research on gravity. Okay, then I'm going to come up with an experiment, and then this time the experiment works, and then that means my hypothesis was correct. Right? No, it just means that that hypothesis works for that particular experiment. And so, so what you could do then is come up with another experiment to test the hypothesis. And then if you do experiment after experiment after experiment, and every time the hypothesis works, well, then you can start to have some confidence in that hypothesis. But remember, you can never prove that a hypothesis is correct. You can only prove that a hypothesis is not correct. So let's look at some definitions here. So what is a scientific fact? It is a repeatedly confirmed observation agreed upon to be true by competent observers. Okay, then what is a scientific hypothesis? It is a temporary explanation for an observation. So it's a guess that answers your question. Okay, then what is a scientific law? Statements based on repeated experiments that describe or predict a wide range of phenomenon. Example, the law of conservation of mass. Another one would be the law of gravity. So it's going to be an equation or a formula that is going to explain or predict a phenomenon, but it's not going to explain the phenomenon. So that's what a scientific theory does. So a scientific theory is an overarching theory that is going to explain a particular phenomenon. So for example, you have the general theory of relativity, and you have the special theory of relativity. You also have the theory of quantum mechanics. So these are very broad theories that help to explain how nature works. All right, so let's take a break, and when we come back, let's take a quiz over what you have learned.